Betelgeuse exploded and something terrifying is happening. Get ready to be astounded by a mind-boggling revelation. A group of scientists has made the astonishing claim that Betelgeuse, the captivating red supergiant star adorning Orion's shoulder, has already undergone a cataclysmic explosion. Yes, you heard it correctly. This is not a joke. Within the next 10 years or a few decades, the brilliant aftermath of this explosion will illuminate the night sky. But how did scientists arrive at this extraordinary claim? Today we're diving deep into the latest details surrounding this enigmatic star. Subscribe to Space Getaway and keep watching to know all about this. Betelgeuse, a red supergiant star, holds a prominent position in the night sky of the northern hemisphere during winter. It is among the select few stars that shine with enough brilliance for us to perceive its striking reddish-orange color with the naked eye. Betelgeuse usually ranks as the 10th brightest star in the night sky. However, as you may already know, it has always exhibited variability in its brightness. One reason for this variability is the fact that Betelgeuse is far from being an ordinary star. It possesses a massive size. To put it into perspective, if we were somehow able to replace our own sun with Betelgeuse, it would extend all the way to the asteroid belt and possess a staggering mass 20 times greater than that of the sun. Surprisingly, Betelgeuse is relatively young for a star, estimated to be around 8 to 10 million years old. In comparison, our own sun is much older, with an estimated age of about 4.6 billion years. The rapid consumption of nuclear fuel in supergiant stars like Betelgeuse causes them to burn through their resources swiftly, leading to their relatively short lifespans on geological timescales. To understand how scientists arrived at the conclusion that Betelgeuse has already experienced an explosion, we must delve into the context and examine the evidence. The tale begins around the 2nd century BC, when Chinese astronomers made the intriguing observation that Betelgeuse exhibited a distinct yellow hue. Moving forward to the middle of the 2nd century AD, Greco-Roman astronomer Ptolemy described it as orangish or ruddy, a description that still holds true today. Similarly, medieval observers in the Middle East witnessed a similar coloration. While we must consider the challenges of naming and perceiving colors in the past, there is a physical possibility that Betelgeuse underwent a color change over a few centuries. It is plausible that Chinese astronomers observed Betelgeuse during its yellow supergiant phase, and over several centuries it transitioned into the red supergiant phase. Given our inherent fascination with the night sky, one can only wonder how many people worldwide noticed this change in the star's appearance, but left no documented records. After all, changes in a star like Betelgeuse likely came with various episodes of dimming and brightening that went unrecorded. Imagine individuals pointing up at the night sky, questioning whether the star used to shine more brightly. Interestingly, Betelgeuse is a variable star known for its cyclic behavior. Starting in December 2019, Betelgeuse's brightness experienced an unusually significant dip that was visibly noticeable to the naked eye. For those accustomed to gazing at this star, it was a departure from its usual self until early 2020. Over time, its brightness gradually recovered, and one theory suggested that some of its natural brightness cycles had coincided, resulting in an exceptionally deep dip. However, observations made by the Hubble Space Telescope revealed something rather peculiar. It appeared that Betelgeuse had expelled an enormous amount of scorching material into space, creating a colossal dust cloud. From our perspective, this dust cloud obstructed a substantial portion of the star's light, causing its striking transformation. Betelgeuse, once counted among the 10 brightest stars in the night sky, faded to the point where it ranked lower than the 20th brightest star. Witnessing its diminished brightness compared to neighboring stars like Aldebaran, which held the 14th position in terms of brightness, was truly perplexing. Astonishingly, Betelgeuse continues to display a state that is even more peculiar than mere dimming. Intriguing, right? We're almost halfway through the video. Subscribe to Space Getaway and press the bell icon to never miss a video from us. Over the past few months, something extraordinary has been happening in the celestial realm. Betelgeuse, the famous star known for its fluctuations, has experienced a remarkable increase in brightness, surpassing its normal luminosity by a staggering 50%. This puzzling situation has left astronomers and stargazers alike unsettled. While dimming events in stars can be attributed to various factors like dust or cyclical patterns, this significant increase in brightness is an entirely different phenomenon. Scientists have been pondering the cause of this enigmatic behavior, speculating that it could be related to an earlier event when Betelgeuse expelled material in 2019, causing disruptions in its plasma flow. This current surge in brightness may be considered an aftershock of that ejection. One conservative hypothesis extensively debated among experts is that Betelgeuse is nearing its supernova phase. However, traditional estimates suggest that this cataclysmic event is still approximately 100,000 years away. But hold on to your telescopes, because groundbreaking research from Hideyuki Sayo and colleagues at Tohoku University in Japan challenges this idea. Their recent scientific paper suggests that Betelgeuse has already undergone a supernova explosion, and we may be witnessing the aftermath of this cosmic spectacle within the next decade or a few decades from now. This discovery is truly astonishing, considering that the last observed supernova in our galaxy occurred in the 1600s. By examining Betelgeuse's variability patterns, the researchers identified 4 distinct periodic changes, each occurring at specific intervals. While the origin of the longest period remains unknown, it is speculated to be the fundamental period, with the shorter intervals potentially serving as overtones. According to their model, Betelgeuse is in a late stage of carbon year burning, indicating that it may be on the verge of a spectacular explosion, making it a prominent candidate for the next expected supernova event in our Milky Way galaxy. But before we get too carried away with excitement, let's consider the conflicting observations surrounding Betelgeuse's ejection of materials and subsequent recovery. The general consensus leans toward a mass ejection event, which is not uncommon for various types of stars, albeit on a smaller scale compared to our Sun. Supernovas, on the other hand, are a different story. We did witness one in a satellite galaxy of the Milky Way back in 1987. While it's uncertain when Betelgeuse will go supernova, it's important not to plan any interstellar vacations just yet. The star is currently hidden behind the Sun and won't be visible until August, leaving us in the dark about its current state. However, Betelgeuse's immense size and proximity provide a unique opportunity to observe direct variations in its light output through photography. Unlike most stars, which appear as mere points of light, Betelgeuse's resolved disk allows for valuable data collection despite the blurry images. Now, let's imagine Betelgeuse undergoing a supernova. It would be a captivating spectacle that poses no harm to our planet. While it wouldn't be the brightest object in the sky, casting its own shadows at night, it would remain visible during the daytime for about a year. Gradually, the supernova would fade away and the familiar shoulder star in Orion would vanish. During this event, animals relying on moonlight for navigation might be confused by the additional brightness and cast shadows. Astronomers and stargazers would also face challenges, as observing the night sky during bright moonlight is already tricky. Nevertheless, many telescopes would eagerly adjust their observations to capture the supernova's glory. Warning signs like neutrino and gravitational wave detections would precede the visible explosion, allowing astronomers to prepare their instruments. Unfortunately, the James Webb Space Telescope cannot observe Betelgeuse due to its overwhelming brightness for the sensitive detectors. However, other ground-based and space observatories eagerly await the chance to capture this cosmic spectacle. Equipped with various instruments, they will strive to unravel the mysteries of Betelgeuse's supernova explosion. Witnessing the event in real time and collecting scientific data would be exhilarating. After the supernova fades, scientists would focus on studying the aftermath, similar to the evolving Crab Nebula, a remnant of a supernova from the 11th century. The outcome of Betelgeuse's supernova depends on the material left behind. It could collapse into a neutron star, or, with sufficient material, become a black hole. Both scenarios are rare, especially considering Betelgeuse's proximity. If it becomes a neutron star, it would be one of the closest to Earth. If it transforms into a black hole, it would hold the title for a considerable time. However, reaching it would require a daunting journey spanning hundreds of light years. Ultimately, when Betelgeuse will go supernova remains uncertain. Surface observations cannot reveal what is happening deep within its core. Although it is currently unstable, it could return to normal cycles and remain that way for decades or even centuries. Alternatively, alternative models suggest the explosion might not occur for tens of thousands of years. Did you find the video informative? Comment below. Subscribe to Space Getaway, and if you want to see more space-related content, make sure to click on the video on your left.